Here's question number 2. I would need a circle here. Okay. So the question says that the equation of a circle is this. Now we know how to extract the center and the radius from this. For the center, also it asks for the center and the radius imparted. Okay, for center, remember you divide the coefficient of x with -2. So -8 upon -2 would be 4, comma, you divide the coefficient of y with -2. So 4 divided by -2 is -2. This is going to be the center of the circle, coordinates of C. And for radius, you do 4 square plus -2 whole squared minus the constant in the question, which is -5. So this comes out to be 25, which is going to be 5. So the radius is 5 and the center coordinates are 4, -2. Okay. Point P 1, 2 lies on the circle, so it would be somewhere over here. 1, 2. So this is P. Show that equation of the tangent to the circle is this. Okay, now you need equation of the tangent. So let's say this is not a good enough tangent. Something like this. It should only touch the circle at this point P. Okay, we need the equation of tangent. So we know from O levels that radius and tangent make a 90-degree angle. Hence, if you connect this, this is going to be a right angle. So now we can find the equation of the circle. Let's find the gradient of PC first. Take its negative reciprocal and then find equation of the tangent. Okay. So slope of PC would be y2 minus y1 over x2 minus x1. That's going to be -4/3. Hence, the gradient of the tangent is going to be 3/4. Negative reciprocal of that because they're perpendicular. Now we're going to do y equals mx plus c. To find c, you need a point on the tangent, which is 1, 2. When you substitute 1, 2 here, we will get this. Then 2 minus 3/4 equals c. This would be 8 minus 3, 5/4. So c comes out to be 5/4. So equation would be y equals mx plus c. We will take the 4 to the other side. Since the 4 is collectively between underneath both 3 and 5, it can go to the other side. Multiply with y, so 4y is equals to 3x plus 5, and this is what we were supposed to get. Okay. Point Q also lies on the circle, and PQ is parallel to the x-axis. So then Q should be somewhere over here. If PQ is parallel to the x-axis. That means we already know the y-coordinate of Q. It's going to be the same as the y-coordinate of P, so that's going to be 2. Okay. Now it says write down the coordinates of Q, so we just need the x-coordinate of Q. Now look at this triangle here. It's an isosceles triangle because these two lengths are the radius. So if it's an isosceles triangle, I mean, it's a very symmetrical triangle. Let's see what is the distance from here to here. It's going to be the same distance from here to here. So here we have 1 and here we have 4. So the distance on the x-axis or along the x-axis, this is 1, this is 4. So that's going to be 3 units. So this distance is 3 units. That means this distance is 3 units. Now we're going to add 3 to 4. We get a 7. So this is going to be 7, comma 2, the coordinates of Q. We did this by movement and through isosceles triangle. Okay. So the coordinates of Q are 7, comma 2. Okay, that's done. The tangent to the circle at P and Q meet at T. Okay, so let's extend this and let's draw another tangent over here and it meets at T. Again, since this line is parallel to the x-axis, it's a horizontal line. That is why these 2 points will be aligned as well. There will be, their x coordinate is going to be the same. So this will be 4 as well. And we still need the y coordinate of this. This is t. Okay. Because these two are also equal. Okay. So now we need the y coordinate of t. For that, we already know this equation. Equation of this line was 4y is equals to 3x plus 5. Let's substitute the value of x here and get the y coordinate of t as well. Okay. So for part D, we have 4y equals 3x plus 5 and t is for now 4 comma y. Substitute 4. We get 17 over 4. So the coordinates of t are 4 comma 17 by 4.